Welcome to our final video, Unit 7, which is on statistics. So, in the beginning of statistics, we talked about how data can either be quantitative or qualitative. Remember, if it's quantitative, that has something to do with numbers. So quantitative is actually over here. Numbers, it's 10 inches by 14 inches. It's 8.5 pounds. It costs $300. Qualitative, which sounds like qualities, where quantitative sounds like quantities, you're just doing descriptions like gold, or it was a peaceful scene, or it smelled old. So quantitative deals with numbers and quantities. Qualitative deals with qualities or characteristics. Then we went in and talked about the measures of central tendency. These you must know. You must know there are 4 of them. They're the mean, the median, the mode, and the range. The mean, remember, is the average. That's where you add up all the numbers and divide by the number of numbers. The median, that's your middle number. Remember, your data must be in order to identify what the middle number is. The mode is the number that occurs the most. So whichever one repeats, sometimes you might have no mode. So if there aren't any repeats, you have no mode. Or if there's a number or several numbers that repeat the same number of times, we can have a few different modes. And the range, of course, is the maximum number, so your highest number, minus your minimum number or your lowest number. When we talk about statistics, we often set up our data in such a way where we talk about quartiles. Quartiles did not have to do with measures of central tendency. We used them more when we were talking about box and whisker plots. So remember, it says we know that the blank of a set of data separates the data into 2 equal parts. So we just talked about that. We know the median does that because the median's right in the middle. So the median splits the data into 2 equal parts, right down the middle. Then we have something we call the quartiles. The quartiles don't just separate the data in half, they separate the original set of data into 4 equal parts. And I remember that quartile split into 4 equal parts because it sounds like a quarter. There's 4 quarters in a dollar. And then along with quartiles, you need to know there is a first quartile, which is the median of the lower half. The second quartile, which is the same thing as the median. And then the third quartile. Of course, also then there is a maximum and minimum. And we used to always get these values from our calculator. So here you are. This is our 5-number summary. That's why we need to know about quartiles. The 5-number summary is your minimum, your first quartile, your second quartile, your third quartile, your maximum. So there's little definitions there. Your minimum is your lowest. First quartile is the median of the lower half. And you see the symbols there too. Min, Q1, Q3, Q2, excuse me, Q3, and max. So remember, the difference between the measures of central tendency, mean, median, mode, and range, and your 5-number summary, which is the min, the first quartile, second quartile, third quartile, and max. We also talked about interquartile range. This is a formula we would often ask you to do. It's a measure of the way your data is spread out. And to compute it, you have to know this little formula, that your IQR is Q3 minus Q1. You guys all did this in your IB projects. So you would have to know your quartile 3, you'd have to know your quartile 1, and subtract them to get an answer. All of this information was important, especially when we talked about box plots. And box plots, remember, sometimes they're called box and whisker plots. You need a few things. You need a number line, and you need to know your 5-number summary. And it ends up looking something like this picture right here. So here's a closer look. You can actually see the different parts. We call this data point the minimum. We call this first bar here quartile 1. This bar here is your median. Here is your quartile 3 and your maximum. You always put the box between your Q1 and your Q3. And then you connect to your max and connect to your min. Hi, Presley. You can be a guest star of the video. What are you looking for?
I had my English essay in here yesterday, and I don't know if it's here anymore.
I'm not sure. You're welcome to look.
I feel like it blew out the window.
It may have blown out the window. You never know, but you are welcome to take a look. All right, sorry everyone, Presley came to visit. So now, moving on to the next part. When we talk about box and whisker plots and data and 5-number summaries, you often hear a lot about outliers. An outlier is just a value in your data that is much larger or much smaller than the rest of the data. So it's way higher or way lower than the rest. Like it kind of doesn't make sense with the rest of the data. Now, you can check for outliers. There's a formula you can use to check for outliers. And to do that, you first of all have to know your interquartile range, which is your IQR, Q3 minus Q1. And then there's the actual test. There's two different versions of the test. There's one way where you test to see if there's any low outliers, any numbers much below the data. And remember, that's Q1 minus 1.5 times the IQR. And you all did this in your projects as well. Then we have a high outlier, which is any number that lies above your data. So if you're testing for a high outlier, the only thing that changes is instead of doing Q1, you do Q3. And instead of minus, you do plus. Okay? You will get these formulas on the final. Let's go ahead and we could test some data. Maybe we should. So the way that we normally do this, and I think I have this in here, maybe not, is we usually put it in the calculator for some of the information because it's nice to get like your min and your max that way. So I'm going to go ahead and go to the calculator. Just give me a second to pull it up. If you have your calculator, you can start typing in that data. Let's see. It's not where I want it to be. Math. I need the calculator. Okay, so let me type in this data. So remember, you go to second stat, oops, excuse me, not second stat, just stat, and then you want to edit, and you want to put those numbers in the list. So 3, 7, 8, 8, 5, 9, 10, 12, 14, 7, 1, 3, 8, 16, 8, 6, 9, 10, 13, 7. And remember, I would always say to go to Stat, Calc, 1var Stats, and we know that your data is in L1, so you do second L1 and you hit Enter. It's not immediately up here. You do see that the X bar is 8.2, that's your mean. But I want to talk about outliers, so I need the 5-number summary data. So if you look here, the min, Q1, median, Q3, and max, that is my 5-number summary. So why don't I just go down a little bit here and I'll record those numbers. Then we'll actually test for some outliers. So my 5-number summary is... And remember, your values are the min, Q1, the median, Q3, and the max. So let me pull those values back up. So what is it? 1, 6.5, 8. I didn't see the last one. 16. All right, great. So if we wanted to make a box and whisker plot here, we could. We could just set up our number line. That's not very straight, but that's okay. We would have 1, 6.5. Remember, you want to space them out as realistic as you kind of can. 8's really close to that. 10's pretty close to that. 16's a little bit higher. So my min and my max. Put a box from my Q1 to my Q3, line down the median. There's my box and whisker. Now, if I wanted to test for outliers, I absolutely could. But in order to test for outliers, remember, you first need to find your IQR. So let's do the IQR, which is Q3 minus Q1. So it's 10 minus 6.5. So 10 minus 6.5, we get what, 3.5? So that's my IQR. Now this is going to be important because if I want to test for outliers, I need to know my IQR. Now we can test for low and high outliers. So let's first test for low. Our low test is Q1 minus 1.5 times the IQR. So Q1, oops, is what? Q1 was 6.5. So I do 6.5 minus 1.5 times my IQR of 3.5. Now remember, with the order of operations, you first have to multiply. So let's do 1.5 times 3.5. I'm just going to quit out of here. 1.5 times 3.5. Good. And then I'll do 6.5 minus what I got in that product. And I end up with 1.25. Now, that's not your final answer, remember. What you need to check now is, did any of your data fall below 1.25? If it did, that's a low outlier. And look, it did. We have a 1. So we do have a low outlier. Our low outlier is 1. Sometimes you have one outlier, sometimes you have none, sometimes you have many. In this case, our low outlier is 1. So let's do a test for our high outliers. The high outlier formula is Q3 plus 1.5 times your IQR. So Q3 I said was, I don't even remember, 10 maybe? 10. So I have 10 plus 1.5 times my IQR, which is 6.5. So again, make sure you multiply first, 1.5 times 6.5, which we did before. Or wait, is it 6.5? No. Oops, my fault. The IQR was not 6.5, the IQR was 3.5. So that's exactly what we multiplied by before. 1.5 times 3.5, you can actually see it, 5.25. So now I'll do 10 plus 5.25, which we know is 15.25. So now if any of our data falls above 15.25, we call that a high outlier. So let's take a look back at my data. Anything above 15.25? Yeah, there sure is. There's a 16. All right, there's a 16. So our 16 is our high outlier. So that's kind of the whole process there. All right, moving along. So we also talked about univariate versus bivariate data. Univariate is single variable, bivariate is 2 variables. A way that we display univariate data, would be like a box and whisker plot. So what we were just doing, that's just one variable. It's just an L1. We start to move into scatter plots where we're comparing 2 variables. So making a scatter plot, remember you just have to make sure you have an X and Y axis. Scatter plots, you never connect the points. Here's an example. Maybe you get a chart that looks like this. You would plot all of these as points. So this would be like 69, 11. This point would be like 65, 9.5. You do that all the way down, plot them all, and don't connect. Usually you have to set up some scale for your x-axis and y-axis. And also you should know what the mean point is. Remember, x bar is the average of your x's. So you would take this data, find the average, and that would be your x bar. And then the y bar is the average of your y's. So you would take the average of all of these, and that would be the number here. Just for the sake of time, I'll save that. But remember, x bar, y bar is the average of the x's, the average of the y's, and you plot that as a point. Your line of best fit should always go through your x bar, y bar point. Once we have a scatter plot, we can describe them in different ways. Remember, if it's generally going up, we say that it is a positive correlation. If it's generally going down, we say it's negative. They're kind of all randomly, we say there's no correlation. And here is the opportunity for extra credit. The extra credit opportunity is on your packet on Tuesday. So please make sure you remember this on Tuesday, next to number 2 or somewhere in your answer for number 2. On the first page, number 2, you need to write somewhere, I love math. Okay, so we're going to look for the I love math. If you have it written, we will give you the extra credit. Now, please don't tell anyone, because if the number of views doesn't match how many people write I love math, then no one will get extra credit. So I love math somewhere next to number 2 or in your number 2 answer. All right, so back to correlation. When we're talking about correlation, there's actually a way to measure it. Remember, our R value measures our correlation. And some things you need to know about the R value. Remember, you do get it from the calculator. If it's positive or negative, that tells you whether the relationship is positive or negative. So if your R value is positive, then you know it's going up. If it's negative, you know it's going down. And it ranges from -1 to 1. Remember, the closer it is to 1 or -1, the stronger the correlation. You can see that here. Really strong positive, really strong negative. If it's at 0, it's completely unrelated. And then somewhere in between, it's like moderately related and positive, moderately related and negative. So your R value tells you a lot of information. This is how you would get the R value using your calculator. This is something we will always give to you. So you always put your data in L1 and L2, and then that's under the LinReg, the linear regression button. And remember, if you're not seeing an R value, just let us know, because we just need to turn your diagnostics on. But here are the steps for you if you need them at home. Okay, and you can always pause if you need to see them all. All right, so here's like an example where you would talk about R and scatter plots. So it says 8 students in Mr. O'Neill's phys ed class did push-ups and sit-ups. The results are shown in the following table. So you have your X values, your push-ups, your Y values, your sit-ups. It says, given the following scatter plot, how would you describe the correlation between the number of push-ups and the number of sit-ups? Well, I'm looking at this and I'm thinking, okay, my data here is generally going upward, but not really strong. So I might say it's a moderate positive relationship. Then they asked me to find the mean point of the data and plot it on the graph. Call it M. So we need to find the average of the x's, the average of the y's, and then put it as a point. So I'm actually going to do that in my calculator to save a little time. So I'm going to clear this out. I'm going to go back to my list. I'll clear out what's in L1. Remember, you just go up to L1 and hit clear enter. So this should be 24, 18, 32, 51, 35, 42, 45, 25. So we can also put that in L2 then for our y. So it'd be 32, 28, 38, 40, 30, 52, 48, 52. All right, so if you do stat, calc, I'm going to go and look at my 1-var stats for L1 real quick to get my x bar, which is the first number. So my x bar is 34, so the average of the x's is 34. Now I can do the same thing for L2. So I'll do 1-var stats of L2. Stat, calc, 1-var stats. Now I'll do second number 2. And my y bar, it says x bar here, but I know it's really my y values, is 40. So my mean point is 34. Somewhere over here. It'll be hard to do because this is so tiny. 40. So my mean point somewhere here. I'm going to call that M. And then it says use the mean point to draw the line of best fit. So you always want to make sure it's going through your data and through M. And there's my line of best fit. Now remember, you can use your line of best fit to make predictions. For example, I could say, okay, well, how many sit-ups do you think if they did 60 push-ups? Well, I can follow that up to my line of best fit, go over, and I'd say, oh, I think if they do 60 push-ups, they can do about 64 sit-ups. So that's what's nice about the line of best fit. And it always goes through the mean point. And that's exactly what I just talked about. It's explain what the line is and what we use it for. We can use it to make predictions about data that maybe doesn't fall in our set of data. Okay, here's finding the line of best fit using your calculator. We'll always give you these steps. It's also under linear regression. Remember, it's AX plus B. So you always know that A, they give you an A value. So maybe it's like 0.273. That always represents your slope. They give you a B value. I'm just making these up. Say it's 1.3247. And then you substitute them into the form y equals ax plus b, which is exactly like y equals mx plus b. Your calculator just calls it a and b instead of m and b. So that is your quick review on statistics. Hopefully you found it helpful. Don't forget about the extra credit for Tuesday. And thanks for watching all these videos. Have a nice long weekend.